Welcome to Norton Chemistry. Today we're going to be answering some Alkanes exam questions. I recommend that you go ahead and answer the exam questions. I'll put the link in the description and then you can go through and check your answers. Under suitable conditions, butane, C4H10, reacts with chlorine by radical substitution. A mixture of organic compounds is formed, including C4H9Cl and compounds D and E. Complete the table below to show the mechanism for the initiation and propagation stages of the reaction of C4H10 with chlorine to form C4H9Cl. In your equations, use molecular formulae and dots with any radicals. So in the initiation step, chlorine is going to undergo homolytic fission, which will form two chlorine radicals, which are species with unpaired electrons, which you represent with a dot. And the conditions are going to be ultraviolet radiation. Chlorine radicals are going to go on to react with butane, forming C4H9 radicals, HCl. So because radicals have an unpaired electron, they're very unstable and therefore very reactive. And then C4H9 is going to react with the Cl2 to form C4H9Cl and Cl radicals. So in propagation steps, we are using a radical and forming a radical, and there's always two propagation steps. And then part II, organic compound D is formed by the substitution of all the H atoms in butane by Cl atoms. Write the equation for the formation of compound D from butane. Use molecular formulae. So that's important, use molecular formulae. So we need to lose all 10 hydrogens. So that's going to require 20 chlorine atoms because we need to form HCl as well. So that's forming C4Cl10 and 10 HCl. And part II, organic compound E is formed by the substitution of some of the H atoms in butane by Cl atoms. A chemist found that 0.636 grams of compound E has a volume of 78 centimeters cubed. Under the conditions used, the molar gas volume is 32.5 dm cubed. Determine the molecular formula of compound E. So, we're not understanding the conditions, but they've given us the molar gas volume. So we can use that to find the moles of compound E, which is going to be the volume divided by 32.5, but since the molar gas volume is given in dm cubed per mole, we need to multiply it by 1000 to get it into centimeters cubed per mole, which is 32,500. 2.4 times 10 to the minus 3 moles of our compound E. And then to find the MR, we do the mass over the moles, which is 0.636 grams divided by 2.4 times 10 to the minus 3 moles, 265 grams per mole. We know it's an organic compound formed by the substitution of some of the hydrogen atoms in butane by chlorine atoms. So we know we must have 4 carbons. So 4 times 12, which is 48. 265 minus 48 is 217. If we try and remove some chlorine atoms as well, because they have a large AR, we know we need to remove at least 2 because we have a whole number, and the AR of chlorine is 35.5. So if we subtract 35.5 times 2 from 217, 146. Which obviously isn't enough to account for all of the hydrogens. We do 217 minus 4 times 35.5. That gives us 75. It's still not enough. So if we do 6 times 35.5, 217 minus 6 times 35.5, that leaves us with 4, which is enough for the number of hydrogens. So that gives us C4H4Cl6. Question 2a. This question is about saturated hydrocarbons. Compound A, B, and C are saturated hydrocarbons. The structures and boiling points of A, B, and C are shown below. So we have a straight chain and 2 branch chains. C is the most branched, B is less branched than C, but it's more branched than A, obviously. So use the structures to explain what is meant by the term structural isomer, and explain the trend in boiling points shown by A, B, and C in the table. So let's go ahead and define a structural isomer. So we have structural isomers are when we have the same molecular formulae, but different structural formulae. So for example, they all have A, B, and C all have molecular formula C5H12. However, structural formula of A is CH3, CH2, CH3, CH2, 3, CH3. B is CH3, 2, CH, CH2, CH3. And C is C, CH3, 4. So, and then we need to talk about boiling points. So explain the trend. So A has the highest boiling point because it is a straight chain, so it has the most points of surface contact between molecules, which require the most energy to overcome. And then you can go on to say about B and C. So B is more branched, so therefore it has fewer points of surface contact between molecules, so it has fewer London forces, which require less energy to overcome than A. And then you can say for C, you can further develop that to say for that it's the most branched, so it has the fewest points of surface contact of all of them, so it has the weakest London forces, which require the least energy to overcome. Part B. Compounds A, B, and C all react with chlorine in the presence of ultraviolet radiation to form organic compounds with the same formula, C5H11Cl. Name the mechanism for this reaction. So this is free radical substitution. Complete the table to show the number of structural isomers of C5H11Cl that could be formed from the reaction of chlorine with A and B. So for A, we just have a straight chain. So we can only have one chlorine because it's a mono substitution. So we can have that isomer, so that's 1, that's 2, and that's 3. But if we were to go at this position, then that would just be the same as this molecule. Sorry, that's terrible drawing. So that leaves us with 3 isomers. And then B, we have a chain that looks like this. So we can have chlorine there or chlorine here, but that's the same isomer. So then we could have the chlorine here, so that's 1, chlorine here, 2, 3, and 4. So that's 4 isomers for B. The reaction of compound A with excess chlorine forms a compound D, which has a molar mass of 175.5 grams per mole. Draw a possible structure for compound D and write the equation for its formation from compound A. Use molecular formulae in the equation. So excess chlorine means we're going to substitute more than 1 chlorine. And since we've got a 0.5 here, that means that we need at least 3 chlorine atoms. Let's try and determine our molecular formula first. So if we're looking to substitute at least 3 chlorines, then we need to subtract 3 times 35.5 from that 175.5 value, which gives us 69. And we have 5 carbons in our chain, so 5 times 12 is 60. That leaves us with 9 hydrogens, which works, right? Because if you subtract 3 from 12, that leaves you with 9. So our molecular formula is C5H9Cl3. And then we can draw any feasible structure we like. So I'll just go with something simple. And then we can write our equation, which is C5H12 plus 3Cl2 goes to C5H9Cl3 plus 3HCl. Question 3. 2-chloropropanoic acid, CH3CHCl, COOH, can be made by reacting propanoic acid with chlorine in a radical substitution reaction. State the conditions for the reaction. So we know that ultraviolet radiation is needed for radical substitution to occur because we need homolytic fission to occur. And let's go ahead and just draw out our 2-chloropropanoic acid so we know what we're working with. And then we write the overall equation for the reaction. So we're reacting propanoic acid with chlorine, CH3, CH2, COOH plus Cl2 forms CH3, CHCl, COOH plus HCl. The first step in the reaction mechanism involves homolytic fission of a chlorine molecule to form 2 chlorine radicals. Why is this step an example of homolytic fission? So homolytic fission, we have breaking of a covalent bond with one electron going to each atom, forming 2 radicals. The chlorine to chlorine covalent bond is broken. One electron goes to each chlorine atom, forming 2 radicals. Write 2 equations to show the propagation steps in the mechanism for this reaction. Use dots to show the unpaired electrons on radicals. So propagation is when we have a radical, we use radical and we form a radical, and we always have 2 equations. So our starting compounds are CH3CH2COOH, so propanoic acid, reacting with our chlorine radical, which will form, we must have the radical on the correct carbon. So we remove a hydrogen from, the chlorine radical removes a hydrogen from that carbon, and that forms a carbon radical, and then we also form HCl, and then that radical, that carbon radical, is going to go on to react with Cl2, break that covalent bond, and forms the final product, which is CH3CHCl, COOH, and also a chlorine radical. And then part 5, draw the displayed formula of the radical formed in the first propagation step. Use a dot to show the position of the unpaired electron. So displayed formula, and then we need to show our radical, and then draw in your hydrogens and your carboxylic acid group. Part 6. Further substitution forms a mixture of organic products. Draw the structure of an organic product formed from 2-chloropropanoic acid by further substitution. So, when we're doing further substitution, we are going to add more chlorines to our 2-chloropropanoic acid. So, for example, we might form a dichloro compound such as 1,2-dichloropropanoic acid. Thanks for watching. Be sure to check out my other videos. I've got lots of revision videos and exam question walkthroughs for you to go through. Also, you should visit my website to purchase my A-Level chemistry notes and my A-Level chemistry flashcards, of which there are 899. You can also book a tutoring session. Send me an email and I'll book you in straight away.